Okay, Assalamualaikum. So we continue with the next input output techniques, which is direct memory access. Okay, sebelum ni we already knows about the program input outputs. Okay, the interrupt drivens. Now we go to the next one, which is direct memory access. Okay, direct memory access is actually the memory set is interrupt driven. Okay, interrupt driven, di mana dia akan dia transfer the data uh, to or from the input output direct to the memory without the CPU intervention ataupun bypass the CPU. Basically, the previous technique such as interrupt driven and the program input output will require the active of CPU intervention. The transfer of data rate is limited since the CPU is not serving the devices. So CPU is tied up with transferring data in and out. So in order to make the performance of your input-output devices, communication and the operations of your devices more efficiently, the DMA is the answer because the direct memory access has the additional module on the hardware on the bus. Okay, so whereby the DMA controller they have their own controller. DMA ni dia ada controller dia sendiri, will take over the CPU punya for untuk input output. Kalau ada interrupt, okay, CPU hanya initiate the first one, okay, take the address where the DMA is ni, and then they ask the DMA to do the DMA controller in order to handle the interrupt instead of CPU. Sebelum ni kalau interrupt driven and program input output, kalau ada interrupt, kalau ada ni, kalau ada interrupt, so CPU need to take part, okay, to handle the interrupt. But for the DMA, dia tak perlukan CPU punya dia boleh bypass CPU dari segi transfer data ataupun transfer data daripada devices atau to the devices into the memory. Okay. Alright, so this is basically is a DMA punya structure. So dekat dari DMA ni dia ada dia punya control logic sendiri. Okay, dia ada DMA request and then dia ada knowledge. DMA ni adalah interrupt driven juga. Okay, tetapi ianya dihandle directly, okay, by the DMA controller. So they have a control logic, dia ada interrupt, okay, dia ada read and writes, okay, of the from to and from to or from devices, and then they have address register, data register and data count lah. Okay, so anything request, okay, from the devices, okay, they go to the DMA request, and then when they receive the data or the send the data, they can acknowledge the DMA. So the interrupt is here. Okay, so they handle their own interrupt, they handle the interrupt directly. Okay, without tak perlu CPU punya tak perlu untuk CPU handle for the interrupts of the devices. Okay. So this is how the DMA. Alright. So let's say the CPU when you CPU execute the programs and the programs require some interruptions. Okay, and then that the devices, okay, have their own DMA. Therefore, the CPU will send the interrupt to the DMA controller, send the address, and then so the DMA controller akan request, okay, because this is a hard disk, okay, so the hard disk drive, okay, require a request, okay, transfer to memory. So dia ada DMA request kan, so DMA request dia akan request, okay, untuk transfer data ke dalam memory. Then what they need to do is daripada disk controller ni dia akan hantar ke memory untuk masukkan data daripada hard disk kepada memory. So bila dia dah masukkan data or write into a memory, so dia akan acknowledge whether they already done the task. So bila tu dia akan hantar, bila the DMA controller acknowledge, then they send back to the CPU. Okay, interrupt dia kata dia dah complete transfer data to the memory. Okay, so they have their own bus. Normally dia attach with the hardware. Okay, DMA ni biasanya dia attach dengan DMA, dengan hardware itself. Okay, so dia punya proses dia nampak macam tanpa CPU terlibat, bukan tak terlibat. Terlibat. Okay, cuma CPU hanya terlibat pada permulaan of the process and the end of the process. Okay, but in the between of the process transferring data to or from the devices to memory, dia tak perlukan CPU punya intervention. Tak perlukan CPU punya intervention, CPU to do the task. Okay, instead of they can direct through their punya controller, direct to the devices, and then the devices will send data to the to the memory. Tak kisahlah. Okay, the DMA ni can be what the CPU need to do is they have to tell the DMA controller whether to read or write to or from the memory. Okay, dia kena bagi the device address. Okay, operation which particular program that require that particular address. So dia perlukan device address, and then dia starting the address, start the address of memory block for the data, and then amount data to be, berapa banyak data that can be transferred. So CPU so that bila dia benda ni, penghantaran data transfer from the devices to or from the devices to the memory, tak perlukan CPU punya operation, tak perlukan CPU punya intervention, so that the CPU can carry with the other works. So CPU can focus more to executions of your other programs. So the DM controller akan deals with transfer, and then they send the interrupt. Dia akan hantar interrupt bila dia dah complete transferring the data to or from the devices to the memory. Okay. Okay, demand cycle stealing. Okay, the ML controller will take over, okay, bus from one or more clock cycle. So the transfer of one words of data is transferred for each stolen cycles. Okay, so when you have the way they stealing the cycle is not in interrupt. CPU tak perlu switch the contact from one process to another process. CPU is a suspend just before it access the bus. Okay, so maksudnya kalau dia use DMA ni, masa dia hantar tu dia tak perlu switch, kan CPU tengah pegang program yang current running. So bila ada interrupt, okay, CPU tak perlu simpan the current program yang ada, dia hold sekejap, dia suspend sekejap, and then dia pergi entertain, bagi tahu kat DMA controller, okay, they have a device required, and then the DMA controller akan deal with the transfer data ataupun the instructions. Okay, once completed, DMA controller akan send a interrupt signal pada CPU, and then bagi tahu this is already is already done. Then dia akan cuma dia akan suspend before they access the bus lah, before the operand ataupun data fetch or data write. They slow down the CPU but not as much as the CPU doing transfer. Okay, macam mana kita configure DMA? So the configuration of DMA depends on the manufacturers, okay, and the spec of the computer. Ada yang like a single bus, okay. So the one DMA, which is shared by the single bus, okay. They use a bus, the same bus of processor, input output and memory also. Each transfer use a bus twice, okay. Dia pakai dua kali lah, okay. From the input output to the DMA and the DMA to the memory. So dia panggil kali lah. So bila DMA require a devices, so DMA controller akan bagi tahu devices, okay, dia perlukan data. Okay, data katakan input devices. So input devices akan hantar data ke DMA, and DMA akan hantar ke memory. Okay, and then so ketika proses penghantaran DMA dalam sistem bus tu, prosesor akan stop, akan suspend twice. Okay, right, itu dia kata twice tu. Okay, ada juga DMA configuration di mana it depends, dia attach the DMA with the input output devices. Ni biasanya devices like a keyboard, like a mouse, okay, like a game device. Okay, so they have the DMA controller. Sometimes kalau kita beli komputer, kita akan nampak dia punya technical specification, dia kata keyboard with the DMA, mouse with the DMA. Biasanya kalau yang with the DMA ni dia mahal sikit lah compare tu yang kita beli yang biasa harga mouse atau keyboard yang biasa. Okay, so yang biasanya kalau yang mahal devices, input device atau output device with their own DMA ni, biasanya dia akan configure like this. Okay, so the attach the DMA with each particular devices, or it can several devices share the same DMA. Okay, so the single bus integrated, this is we call integrated DMA controller, di mana dia akan attach for integrate with the input output devices. The controller may support more than one devices macam ni kan. So one DMA dia akan support more than one input output devices. So yang ini dia akan transfer use bus as a once. Okay, iaitu antara DMA to memory. Macam tadi dia sebab DMA tu satu, jadi dia share the same bus. Yang ini walaupun dia share the same bus, tapi yang ni dia bila dia attach dengan input output sendiri, maka dekat sini dia ada dia own system bus sendiri. Jadi proses data untuk dia hanya guna the shared bus tu hanya bila dia nak hantar data kepada memory. Jadi bila dia nak daripada data read or write to or from the devices to DMA, dia tak terlibat dalam, dia have their own bus. Okay, they have their own bus. Okay, instead of they share the same memory. So yang ini super processor hanya suspend one sahajalah, compare yang macam tadi lah. Okay, untuk DMA configuration, the next one. Okay, yang ini dia separate input output di bus. Ini lain. Okay, so yang ini the way they configure ialah the DMA will share the system bus. Okay, tetapi DMA ni dia akan have their own separate input output bus. Yang ini mahal lah biasanya. Okay, so dia ni dia mahal kerana they have their own input output bus punya system bus, and then each transfer is bus once. Okay, maknanya dia hanya menggunakan the main system bus untuk hantar DMA kepada memori. Sama juga yang ni. Cuma the way configuration dia ialah dia punya DMA have their own input output bus. Macam tadi dia attach DMA itu dekat setiap devices. Yang ini the way the DMA dia configure ialah the DMA will have their own input output bus. Okay, so input output devices akan attach the input output bus, and then this output will share among the input output devices, and the DMA akan hantar request ataupun acknowledge through this input output bus lah. Okay. Alright, that's a DMA. Okay, so kita dah tahu input output. Okay, so bila kita kata input output, the transfer it depends on the interface. Okay, ataupun kita kata input output channels. Okay, so your input output devices are getting more sophisticated, more high end. Okay, because some of the devices can do both. In the same time, input and output at the same time. For contohnya your printer, all-in-one printers. Okay, all-in-one printers you boleh scan, you boleh print. Okay, you boleh scan and you boleh print, you boleh photocopy dalam masa yang sama. So they can be input and also they can be output at the same times. Okay, ada juga your wearable devices like your camera digitals, your smartwatch. Okay, they can be both input and output devices. So the CPU will instruct the input output controller to do the transfer, and the input output controller does the entire transfer. So the input output controller needs more processing power, and it's a small CPU, and they need a channel or the processor to improve the punya overall system speed. Okay, kita tak boleh take loads of the CPU. Kita kena kurangkan beban daripada CPU sebab CPU banyak benda dia nak kena execute. Okay, banyak benda dia nak kena fetch the program and execute the program. So input output channel, when we have a dedicated of the input, when we provide the other way of input output channel, so it can be improve your speed of your computer also. So we have a dedicated processor. Bila kita dedicated the channels tu untuk processor, so it's much very faster lah. So daripada kita share the same channel. Okay, so normally kita have an interface. Okay, each devices they has an interface. Okay, contohnya kita ada SCSI, okay, the small computer system interface. So this is actually a parallel interface. Sama ada the 8, a 16, a 32-bit data lines. Okay, kalau you boleh tengok dekat dalam SCSI punya hadis, okay, so dekat dia punya port tu itulah dia punya interface lah sebenarnya. Okay. Alright, so they have ada yang jenis port yang jenis parallel, okay, ada yang jenis serial, okay. So this channel main peranan, okay, when you transfer the data to or from the devices to the computer. So the change must be terminate at the each end, and usually they have a host adapter. Okay, so this type of interface are plug-in, terminator or switches. So the device can communicate each other as well as a host. Okay. Ada juga yang berbentuk serial. Contohnya Universal Serial Bus. Okay, USB port. You tahu USB kan? So USB port tu. So USB using a serial bus. Di mana they use the rest of all the devices. Sama ada keyboard, mouse, parallel and any devices that use a serial up to 127 devices. So this particular port ataupun interface are using a serial transmissions. Normally they're very low speed compared to high speed. Okay, they normally hierarchical topology. It depends on the hierarchical topology, protocol and also depends on the cable. So nowadays USB kita pun dah 3.0 and 4.0. So the speed must be faster. Okay, compared yang dulu lah. Okay, compared to macam ni USB 1 dulu, dia boleh hantar data dalam masa 840 megabyte per second. USB tu lebih lah. Okay, so the hot connection of devices, maknanya dia tak perlu turn off. Okay, no need to turn off and automatic configure the firewire. Okay, yang ni firewire lah. Okay, USB dia cucuk terus masuk. Okay, we have a firewire. Firewire ni sekarang ni ada yang pakai, ada yang tak pakai. Okay, some of the computer nowadays dah tak ada dah pakai firewire. Okay, firewire ni they use a serial bus. They're fast, low cost and easy to implement. Okay, firewire port ni dulu kita banyak gunakan untuk VCR video cam recorder. Okay, ataupun you perasan tak kalau you ada video cam recorder tu dulu and then you connect to your TV and you want to connect to your PC, so dia pakai firewire port. Okay, in order to as an interface in order to connect and transfer data from your digital camera or your camcorder to the TV. So dia pakai up to 63 devices. Firewire port ni boleh pakai sampai up to 63 devices. Automatic configuration and data rate dia transfer data rate dia antara 25 to 400 megabit per second. Okay, nowadays the firewire port will not be used. Okay, so ini antara interface. So biasanya interface dia ada dua, satu serial, satu lagi parallel. So the way kalau serial dia akan transfer data you secara bersiri, and parallel dia akan hantar the data will be sent into a parallel punya bits. Okay, kalau bersiri, okay, dia secara bersiri of the bits, and then parallel dia akan buat secara selari dalam masa yang sama. So parallel port, so the interface bergantung kepada the way it can be transmitted. Either is serial ataupun parallel port. Okay, normally yang ni kita banyak tengok on the external devices lah. Okay, contohnya you punya USB, keyboard, mouse. Okay, yang bukan built-in tetapi yang external, yang you have a plug-in. Okay, dia cucuk and automatically detect and then they can do the transfer data from devices or to the devices. Okay, so that's all for the DMA part. Okay, so I hope you can understand and read through this basic need to be understand. Okay, in order for you to go to the semester 3 punya subject of principle of operating system, because yang ni dia akan digunakan lagi. Okay, sebab kita tak nak sentuh sangat you punya DMA dekat sini sebab nanti dia akan digunakan lagi dalam you punya operating system. Tapi you at least to know, okay, bila input, output, communication ni dia ada teknik, dia ada beberapa teknik. Okay, so kalau program input output macam mana, interrupt macam mana, DMA macam mana. Okay, so DMA dia interrupt driven juga. Dia adalah jenis interrupt, cuma dia ada their own controller, and then dia transfer data from devices or to the device, from the devices to the memory tanpa perlu CPU, or bypass the CPU. Tak perlu CPU punya intervention lah, tak perlu load bebankan pada CPU untuk transfer data from devices to the memory. Okay, that's all.